Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing chemical properties of carboxylic acid. In that I have discussed reaction due to cleavage of OH bond. Now I am going to discuss reaction involving cleavage of COH bond. COH bond, C and OH bond. Last class I have discussed O and H bond. Now I am going to discuss cleavage of COH bond, reactions involving cleavage of COH bond. Under that, first reaction is formation of anhydride. Carboxylic acids on heating with mineral acids such as H2SO4 or with P-2O5 give corresponding anhydride. Reaction is very simple. You have to take 2 molecules of ethanoic acid, means acetic acid, CH3, C double bond O and COH. Correct? CH3, C double bond O and OH bond, COH bond. Like that way, other one more molecule you can consider, that is the second molecule of acetic acid, and you have to place in such a way that C double O and OH group of both molecules should be close. Then you will find that OH of first molecule and H of second molecule, it will form water. Because OH will go, when bond will break, COH bond, then OH will go as a negative charge and carbon will have positive charge. And from the second molecule, H bond will break, H and O bond will break. Then H will go as H plus, then OH minus and H plus. It will form water. Then now that carbon was having positive charge and oxygen was having negative charge. When hydrogen went as H plus, then O was having negative, then this negative oxygen will join the positive carbon and ethanoic anhydride will form. Oxygen will join to negative, oxygen will join to the positive carbon. Then now ethanoic anhydride is formed and C double bond O. Now it is present in both molecules, CO already it is there. Hence now you got CH3, C double bond O, and again other molecules when joined, then in the middle oxygen is there. Oxygen is making link with both molecule. Oxygen in the middle. Then one side CH3CO, other side also CH3CO. And in the middle oxygen is there. Oxygen is making link with both carbon of CH3CO. Now other reaction I am telling you, that is the esterification. Esterification means formation of ester from carboxylic acid and alcohol. Carboxylic acids are esterified with alcohols or phenols in the presence of mineral acid such as concentrated H2SO4 or HCl gas as catalyst. Then reaction is very simple. HCOOH. Then you know R you can consider RCOOH. R is alkyl group. Then COOH, you know that one oxygen has double bond with carbon and other is OH, which is attached to carbon. Then this carboxylic acid, when it will react with ROH, then what will happen? That ROH, that R and OH bond will break. Then R will become positively charged, OH will become negatively charged. Then here from carboxylic acid, from the carboxylic acid what will happen? That H will go as H plus. Then O will get negative charge. Then O is getting negative charge. Then from this negative charge, R positive will come from ROH, because that also ROH bond will break. Then R will come as R plus. And ROH bond will break, R will be positive charge, OH will be negative. Then that R plus will come to the this O negative of carboxylic acid, because H gone as H plus. Then O minus is remaining. Then with this O minus, R will join. Then it will form RCOOR. Here ROH, R dash is there. Both are maybe the same or different. Then whatever we RCOO, R you will get. One R may be different. Maybe both are different. Sometimes same. And other product will be H plus and OH minus. That is the H2O. Correct? This then here ester is formed. Ester means RCOOR. Both are maybe same, maybe different. Okay. Then its mechanism is very easy to understand. Already what I told you, same way you can understand mechanism of esterification of carboxylic acids. The esterification of carboxylic acids with alcohol is a kind of nucleophilic acyl substitution. Protonation of the carbonyl oxygen activate the carbonyl group between nucleophilic addition of the alcohol. Proton transfer in the tetrahedral intermediate converts the hydroxyl group into OH2, means O will be positive charge, OH2, then O will be positive charge, OH2, okay, which being a better leaving group is eliminated as neutral water molecule. The protonated ester so formed finally loses a proton to give the ester. Reaction is very simple. Here one molecule first to take carboxylic acid. Now in presence of acid, reaction will take place. Then what will happen here? Acid means H plus. Then that H plus will come near the double bond. Oxygen is there. Oxygen, it will come near the oxygen which has double bond. Then that bond will break. Double bond will become single bond. Okay. Then many times I told you, when double bond will break, then electron will be taken by oxygen. It will become negative, and carbon will become positive because its electron also taken by oxygen. Then oxygen is negatively charged and carbon is positively charged. Then H plus of acid will make a bond with oxygen. O negative oxygen, it will go to H plus will go to the O negative, and it will form OH. Correct? OH. And bond will become single bond. And what about the C plus? C plus. Then there C plus only negative charge will come. Then here that H plus, it may come to the from the ROH also. ROH also. Then RO, that will be negative, and H will be positive. That H you can understand like this way also. H plus may come through NOH also and through HCl also. Both way if HCl, then HCl or H2SO4 means acid, then that will provide H, or if NOH, then that will also provide H plus. Then remaining will be RO minus. Then that here actually you are using here NOH or ROH. Okay, maybe ethyl alcohol, ROH. Then the O and H bond will break, then H will take positive, O will become negative, means RO is negative, that negative carbon will come to the positive carbon, means carbocation of carboxylic acid, when double bond becomes single bond that time. Then here that oxygen O that minus, O minus is there in RO, O is minus, that has joined with carbon. Then now you can say this OR, now it is attached to the carbon, correct? And obviously that it will join only when H will go, ROH will be not there. Then here you have seen that what will happen actually here, that reaction will be sometimes this breaking and forming the bond, both will take place together simultaneously. Okay, one bond will break, other bond will form. Correct? That's why I told you that what will happen finally. But here ROH will reach to the carboxylic acid. Then H plus will join with O, and that double bond will become single bond. Then it formed OH, and O has joined with carbon. Then in the carboxylic acid already one OH group is there, and now this OR, now it is attached. Correct? Then what will happen, that now 2 OH is present on the carbon. 2 OH group is present on the carbon, joined with carbon. Then what will happen, that OH and H of other hydroxyl group, OH. From that H, another is again one OH. Then this OH, both bond O and H, 2 OH bond, 2 OH group is there. Then one OH bond will break, carbon OH bond will break. Then you know what will happen, OH will go as negative, OH minus, and carbon will be positive charge. Correct? Then now OH is minus. Then here what will happen, now second bond also will break, OH second bond. Then here actually that OH bond, this carbon oxygen bond will not break, O and H bond will break. Bond between O and H, that bond will break. Then you know here what will happen, H will go as H plus and O will be negative, because electron will be taken by oxygen. Then this H plus and OH minus, that will form water, H2O. Correct? Now carbon is having positive charge and oxygen is now negative because H gone as H plus. Second OH I am talking about, only H has gone, O is there, it is negatively charged and carbon is positive charge. Then easily you can make one bond, then now CO bond was single bond, now it will become double bond because oxygen has an electron that will give to the carbon, or oxygen is negative, carbon is positive, then it can form one bond. Because two electron is there, one electron belong to oxygen, other belong to the hydrogen who left, who went without electron. Then that two electron, because to make one bond, two electron is required. Then that two electron actually will be given to, or you can say this two electron will make bond between carbon and oxygen, correct? And it will form double bond. Or simple way, carbon plus O minus both will join and it will form double bond. Then like that way, now you got RC double bond oxygen, C and O double bond and OR joined. OR joined. This is called ester. Here generally proton transfer will take place. Proton transfer takes place. I told you OH and H, it will form water and it will go. That will be finally only this thing will happen. Now third reaction I am telling you, that is a reaction with PCl5, PCl3 and SOCl2, means thionyl chloride. Then here also OH bonds, C and OH bond will break. RC double O, RC double OH is there, then one oxygen is double bond, always you remember, and one OH is single bond attached to carbon. C and OH, that is single bond. Then now always you remember C double OH in this structure. Then reaction you will understand very easily. And I told you that sometimes bond between O and H will break, sometimes C and OH, that bond will break, correct? Two possibilities I told you. Okay, third possibility is third type of reaction due to carboxylic acid I will also tell. But now just a cleavage of COH bond, based on that now you understand. That is a reaction with PCl5, PCl3 and thionyl chloride, means SOCl2. The hydroxyl group of carboxylic acids behaves like that of alcohols and is easily replaced by chlorine. Easily it is replaced by chlorine atom on treatment with PCl3, PCl5 or SOCl2. Here you remember that this Cl minus and OH minus both are negative charge, and it can substitute. Both are negative. Always substitution takes place in the same charge, you remember. Okay. Then here what will happen? Now the hydroxyl group of carboxylic acid behaves like that of alcohol and is easily replaced by chlorine atom. OH is minus, Cl is minus. That's why easily replaced by chlorine atom on treatment with PCl5, PCl3 or SOCl2. Thionyl chloride means SOCl2 is preferred because the other two products are gaseous and escape the reaction mixture, making the purification of the products easier. Okay, thionyl chloride is preferred. Why? Thionyl chloride is preferred because the other two products are gaseous and escapes the reaction mixture, making the purification of the products easier. Okay, Then reaction I am telling you, RCOOH, RCOOH. Then one oxygen bond, double bond will not break. Always you keep in mind. Only single bond OH, that bond will break. Then RCOOH plus PCl5. Then here OH will go and in its place Cl will come from PCl5. Then now you got RCOCl. OH was minus, in its place Cl minus came. Very simple way. Then you got main product RCOCl. Now PCl4 is remaining, means one phosphorus and 4 Cl is there. Then what will happen here? That you have seen here OH gone from the carboxylic acid, OH. Then there O was there and H was also there. Then this H of OH, that bond also, OH bond will break. Then H will go as a H plus, then this H plus and Cl from the PCl5, it will form HCl. Then now 2 Cl gone, then 3 Cl is remaining and 1 oxygen is remaining. Correct? Then 3 Cl is remaining and 1 oxygen is remaining and 1 phosphorus is remaining, because you have taken PCl5. Then in the place of 2 chlorine, oxygen will come. Oxygen is negatively charged. Correct? It is equivalent to 2 chloride ion, but 2 negative charge. Each chloride has 1. Hence, for the 2 chloride ion which gone, in its place 1 oxygen can join with phosphorus. Then phosphorus was having 5 positive charge. And now 2 is 5 positive charge. The charge means negative charge. Then already 3 is there. 3 Cl is attached. Then now 1 oxygen will join. Then now all 5 valency of phosphorus is fulfilled. Correct? 3 Cl is attached already, and for the 2 Cl which gone, in its place 1 oxygen came. 1 oxygen means 2 negative charge. Then now you got POCl3. POCl3, phosphorus oxide trichloride, POCl3. Then you got 3 product. First product you got RCOCl, second product POCl3, third product HCl. You remember this reaction is very, very important. In all examination, this question is asked. Okay, this reaction is useful. Now you can say other reaction with PCl3. With PCl3 means carboxylic acid plus PCl3. Then here you will take 3 molecules of carboxylic acid, RCOOH, 3 molecules you will take. Why 3 molecules you will take? Because here that 3 Cl will attach, then 1 H will go, 1 OH will go, OH minus, and in its place 1 Cl minus will come. Then if you will take 3 molecule of carboxylic acid, then it will go 3 OH and in its place 3 Cl will come. Then you will get RCOCl, 3 molecules you will get, 3RCOCl, COCl, because in the place of OH, Cl came. Both are negatively charged. Correct? Then you will get 3RCOCl, main product. Okay, that is called acyl chloride. And now this 3OH gone. Then 3OH means 3 oxygen, 3 hydrogen. Correct? And now phosphorus is without chlorine, means 3 positive charges there. 3 positive charges on phosphorus. Then now what will happen? This P wants 3 negative. Then how will you get this? Then now just here 6 hydrogen, this 3OH gone, means 3H and 3O is available. Then 3H means it can form H3PO4, PO3, H3PO3. How? Just to think. H3PO3. See, phosphorus is having 3 plus. Then now 3 oxygens are there. Then 1 oxygen means 2 electron. Correct? Then okay, when it will join with phosphorus, then 3 negative charge will be there. Okay, each oxygen will have, you can say 3 negative charge. Correct? Then here what will happen? Now 3 hydrogen is there, positive charge. Then now each hydrogen will join to the each oxygen, which was having negative. And now 3H will join. Then you will get H3PO3. Correct? You can write like this: H3PO3, phosphorus acid. Okay. H3PO4 is called phosphoric acid. Here it is the H3PO3. Now another reaction I want to tell you, that is with thionyl chloride, SOCl2, means carboxylic acid plus SOCl2. This reaction is again very important reaction. Remember, this reaction is also asked in examination in different form. Then here also same thing will happen. RCOOH is there, then 1 oxygen will not disturb because it's a double bond. Then OH bond will break, C and OH bond will break, and in the place of OH, Cl will come. Then now you got the main product, RCOCl, means acyl chloride. In all 3 reactions you got acyl chloride. Now think for the other products. Then 1 H gone, 1 OH has gone and 1 Cl joined. Then 1 OH gone means what will happen? That SOCl2 was there. Then 1 Cl replaced with OH. In the place of OH, 1 Cl gone there. Then now 1 Cl is remaining. 1 Cl is remaining with that is the SOCl. Then now that Cl will also bond, that Cl will also go from the SOCl to both Cl will go. Then whenever it will go as Cl minus. Correct? Then now what will happen? That H plus from the OH, then that O will become 2 negative charge. OH was there, 1 negative. Now H is also going as H plus. Then O will be double negative. H will be positive. Then this H plus and Cl from SOCl2, second Cl, it will form HCl, second product. Then now what will happen to this oxygen which has which has two negative, which has two negative, means two pair of electron. Then wherever it will go, it can make double bond. One pair means one bond, two pair means two bond. Then now we have seen that from the SOCl2, now this 2 chlorine gone, means 2 negative gone. Then now there oxygen can join there. One oxygen is equivalent to 2 Cl. 2 Cl gone, Cl was negative, then one oxygen can join there. Correct? 2 Cl gone, negative charge. Then oxygen, one oxygen atom having 2 negative charge, that will join with sulfur. Then what you will get? SO2. Already one oxygen was there, SOCl2, SOCl2. Then SO was there, only 2 Cl gone, and in its place one oxygen joined. 2 Cl gone means 2 negative gone, but here oxygen is already 2 negative, hence it can join with sulfur. It will form SO2. I think you have understood. Now next reaction I am telling you, reaction with ammonia. Reaction with ammonia. This is also very, very important reaction. Carboxylic acid react with ammonia to give ammonium salt, which on further heating at high temperature give amides. For example, now take acetic acid, CH3COOH plus NH3. Then now easily you can understand what will happen. That CH3COOH, then H will go as a H plus, then O will have negative charge. Means C double bond O, that will not disturb. Okay, OH, from that OH, H will go, then oxygen will be negative. Oxygen will be negative. Then what will happen here? That here you should also remember that NH3, that N has a lone pair of electron. N has a lone pair of electron. Then when H plus will reach to the ammonia gas NH3, then lone pair of electron of ammonia, N has lone pair of electron, that it will give electron to the hydrogen and it will make coordinate bond. Correct? Then because it has donated one pair, then N will get a positive charge. Then now you got a NH4. NH4 you got 1 plus. Correct? NH4, NH3 was there, now H has joined and N is positively charged now. Then now you got ammonium ion. Then this positive charge ammonium ion will make the bond with oxygen of carboxylic acid. Then you will get ammonium acetate. You will get ammonium acetate, means CH3COONH4. This is actually salt, weak salt. Then now this is actually this ammonium salt that will actually, this is unstable. Then what will happen? That NH4 is there, here 2 oxygen is there, CH3COONH4. Then 2 hydrogen from ammonium ion which is joined, and one oxygen atom of ammonium acetate, that will make H2O. It will go out. Correct? Because these bonds are unstable. These molecules are unstable. Ammonium state is unstable. Quickly 2 hydrogen from the ammonium ion, correct, and 1 oxygen from the COO, that will go as water minus H2O. This will happen on heating, okay, not simply. If you will heat, only then it happens. 2H and 1 O, it will form water. Then what is the remaining? That is acid amide, because now it is remaining CH3CONH2. C double bond O is remaining, and actually that OH, OH bond was single bond, C and OH. Actually that bond has broken. Really. Then there actually when water will go outside, then there only NH2 will remain, because C double bond O, that will not break. Then carbon will have positive charge. Then when H2O will go, H2H and 1O it will go, then when oxygen will go, you know that it will go by taking its electron. Then that carbon become positive and hydrogen will go as H plus. Then nitrogen will become negative. Two hydrogen is going, and hence nitrogen will have negative charge. That will join with positive carbon, and it will form CH3CONH2. NH2 will join to the carbon, and double bond oxygen, carbon and oxygen, that is a double bond that will remain. Okay, then you got acid amide. Same way, if you will take benzoic acid means with phenol, COOH is there, carboxylic group is there. Then same type of reaction will take place with ammonia gas, and here again you will get ammonium benzoate, that is the unstable, and same way H2O will go outside and CONH2 will remain. And already with this CO, benzene is attached. Means CO is there, one side benzene, other side NH2. This is called benzamide. Okay, and now if suppose phthalic acid is there, then what will happen? Means in benzene ring, 2 carboxylic acid is attached. Suppose one is at both are adjacent, both COO is at adjacent carbons. Means suppose 1 and 2, carbon 1 has COH group, carbon 2 also has COH group in benzene ring. And now reaction is going on with ammonia gas only. Then now what will happen? Quickly you can understand that here 2 molecules of ammonia is required. Then same thing will happen, that 2 molecules of water will go. NH3 is there, or in a direct way you can understand that OH, COOH, OH is there, then 1 H from the NH3, that will make water, OH minus and H plus, water. It will go as a H2O. Then one now bond form between nitrogen and carbon, because OH bond gone, then carbon will have positive charge, because OH was having negative charge, it went as negative. Then now when H went as H plus from ammonia, then N became negative, then that N joined with positive carbon, negative N joined with positive carbon. Now it has joined N C and N bond formed. But now on nitrogen two more H is there. Two more H is there. Then what will happen? One more hydrogen will join with OH of the as second COOH is there. Then this one H and that OH, second COH, it will form water and it will go as H2O. Correct? Then second H2O is formed. Then again carbon will become positive, nitrogen is negative. Then that nitrogen and negative nitrogen, because H gone as H plus, then nitrogen become negative, and OH gone from the COOH, OH gone. Then OH gone as OH negative and carbon become positive. Then again same way nitrogen will join with carbon. Then on nitrogen only one H is remaining. But this nitrogen has joined with both carbon, COOH, COOH, two carboxyl group are there. Then now this nitrogen has joined with both carbon, and on nitrogen one hydrogen is there. Then actually it will not, what I told you, that is the final. That is the final I told you, but intermediate will be formed. Means NH3, 2 NH3 will take, then it will form NH4 plus, means what I discussed earlier, it will form ammonium salt with both COOH group, that is called ammonium thiolate. COO NH4, because O will be negative, NH4 will be positive. Then with both carboxylic group, it will form salt, that is called ammonium thiolate. Then this is again unstable. On heating what will happen? Water will go. Water will fall. As a water it will go. Okay. Then only CONH2 will remain. On CONH2, now COOH converted to CONH2. On both carbon CONH2. Then after that again what will happen? That on a strong heating, that NH2 is there, then it will form NH3. It will go as ammonia gas. Only one nitrogen will remain. That will make bond with carbon. Okay. Then what I told you in the beginning, that you will get this thing, with benzene ring 2 COOH was there, then now only CO is remaining on CO, C double bond O is remaining on both carbon, and both carbon is joined through nitrogen, and one H is remaining. That is called thialamide. Okay. This reaction is also important. Means the structure became like that. Benzene ring is there, adjacent carbon, first carbon COO, and that C is making bond with NH, and other adjacent carbon also they have CO, and that carbon is making bond with NH. Means N is joining with both carbon. Okay, this is called thialamide. Now I have discussed two types of reaction. Chemical properties based on breaking of O and H bond, and second breaking of C and OH bond. Okay. Now this other reaction is there. Some reactions are there involving COOH group, means acid group, direct COOH. Some reactions are based on that. Then that is actually reduction reaction. reduction. Then here two main reactions are there involving COOH group, carboxylic group. First is reduction, second is decarboxylation. One by one I will tell you. Carboxylic acids are reduced to primary alcohol by lithium aluminum hydride or better with diborane. Diborane does not easily reduce functional groups such as ester, nitro, halo, etc. Okay. Sodium borohydride does not reduce the carboxylic group. It means lithium aluminum hydride is only suitable for the reduction of carboxylic acid. Question is asked, I am repeating. Carboxylic acids are reduced to primary alcohol by lithium aluminum hydride, means LiAlH4, in presence of ether. Sometimes diborane is also required, means in the presence of diborane also reaction takes place. Okay. But a special things, diborane does not easily reduce functional group such as ester, nitro, halo. This is the exception. Diborane will not easily reduce functional group like ester, nitro and halo. Sodium borohydride, you are using now here lithium aluminum hydride, but sodium borohydride NaBH4, that is also reducing agent. Then sodium borohydride does not reduce the carboxyl group. Then here what is the reaction? Then RCOOH, that in the presence of lithium aluminum hydride and ether or B2H6 diborane, that one oxygen will go as H2O. Then only one oxygen will remain. That is called RCH2OH. RCH because it will supply hydrogen. Reducing agent will supply hydrogen. Then here for one oxygen, two hydrogen, just to remove one oxygen, two hydrogen is required, it will go as a H2O, and two more hydrogen is required because oxygen is going, carbon has tetravalency. Then now when this one oxygen will go, in its place two hydrogen will come. One oxygen is equivalent to two hydrogen. Then it will form CH2OH. R is already attached, then RCH2OH. Okay, that it will form. Means carboxylic acid forms alcohol. Second, I am telling you decarboxylation. Decarboxylation means carbon dioxide will go outside in the form of carbonate. Carboxylic acid lose carbon dioxide to form hydrocarbons when their sodium salts are heated with soda lime. Soda lime means sodium hydroxide and calcium oxide in the ratio of 3:1. This reaction is known as decarboxylation. Then RCOON plus NOH plus CaO. It will, or you can take RCOONA when it is heated in presence of NOH and calcium oxide, that COO, that will go as CO2. Correct? and already you have taken RCOOAN, ONA, that is actually salt. Then one more sodium will come from the NOH, correct? And or you can tell NaO is there. NaO directly NaO will come. It will form Na2CO3. Now one oxygen is coming from NaO. Sometimes may come from the calcium oxide, that oxide also. Okay. Then it will form Na2CO3 because it is coming as a NaO. O is negative charge. Then now it will form Na2CO3. Na2CO3. And NOH was there, then H was having H plus. H plus. Then here it will join to R. R is actually R minus. Carb anion. Because when carbon will go as this thing, when this R and C bond will break, then R will be negative charge. R will be negative charge. Then with this R, H, R will have positive charge, then H will come negative. No, R will be negative, H will come positive. It will form RH. Then here you will get a hydrocarbon. Okay, here you will get hydrocarbon RH. Alkali metal salts of carboxylic acids also undergo decarboxylation on electrolysis of their aqueous solution and form hydrocarbons having twice the number of carbon atoms present in the alkyl group of the acid. This reaction is known as Kolbe reaction. Alkyl group, water is in number, if it is 2, then it will form alkane of double carbon, means like 4 carbon. If it is one carbon, then methyl was there, then it will form ethane. If 3, then it will form 6 carbon hydrocarbon, means hexane. Okay, this is actually, this reaction takes place. Two conditions are there, that should be the alkali metal salt of carboxylic acid. That is the first requirement. Alkali metal salts of carboxylic acid. And reaction will take this, actually electrolysis. Electrodes is required in a cell. This reaction takes place. This is the electrolysis of their aqueous solution, means alkali metal salt of carboxylic acid should be in the presence of in the solution, aqueous solution. Then it will form hydrocarbons having twice the number of carbon atoms present in the alkyl group of the acid. The reaction is known as Kolbe electrolysis. Okay, then now I am stopping only here, and that a few more reactions are there that I will discuss next class. Okay, thank you.